And speaking of complexity, that's a nice transition, so thank you, Tara. My name is Jack Friedman. I'm a cultural anthropologist in the Center for Applied Social Research at the University of Oklahoma. Sorry, I do a lot of collaboration with other universities. I forget my own affiliations sometimes. The context for my comments is a project that has involved collaboration between environmental anthropologists and modelers examining the socio-ecological intersection of drought, water limitations, human behavior, and ecosystems along the Rio Grande, Rio Bravo region. I'm just going to call it Rio Grande for this paper. The collaboration has been ongoing since 2015 and involved 15 months on our part, the side of the anthropologists. 15 months of in situ ethnographic fieldwork in the Rio Grande, conducting interviews with and significant participant observation of people and communities who quote unquote manage water in the broadest use of that term, so as to include not only formal resource managers, but also and especially farmers who are responsible for the management and consumption of 83.5% of the water in order to irrigate a mere 3.5% of the basin. So the work that I and my postdoctoral researcher, Dr. Stephanie Palladino, conducted in the basin was focused on capturing an understanding of how these water managers interact with not only their own local relationship with the river, but also whether there are instances of what we term whole river thinking. The idea that hyper-localized actors might weigh their own decisions about their local and immediate needs and concerns against the needs of those people and ecosystems that might be hundreds or thousands of kilometers upstream or downstream from where they are. This is a particularly difficult challenge in the Rio Grande because, among other things, the basin is so profoundly impacted by political, legal, cultural, ecozone, land use, and most importantly, hydrological fragmentation across the over 3,000 kilometers of a river that crosses 2 countries, the US and Mexico, 8 states, 3 in the US and 5 in Mexico, and 13 ecozones. The collaboration at the heart of this project was new to everybody on the team. While the modelers, Dr. Jennifer Koch and her postdoc, Sophie Placine, had worked with social scientists before to develop agent-based models, they'd never worked with anthropologists who were collecting a broad range of very detailed data on how people conceive, perceive, understand, and ultimately behave regarding the environment. The anthropologists had only worked tangentially with modelers, primarily providing background summaries to modelers who had drawn on less intimate social data for their actual modeling work. As such, we found a need to develop clear methods for sharing data and explaining what we were each doing in order to develop the conceptual models necessary to get to the point where we could even imagine building an agent-based model of the Rio Grande, a process that we documented in Koch et al. 2019. At the heart of this effort was the troubling problem of the complexity of agents in the model. And by complexity, let me just start by running through how complex things could get when dealing with even one type of actor across a basin as large as the Rio Grande, a farmer. As we found, each question about how to characterize farmers from different standpoints, what characteristics they would have, what decision-making rationality we would give them, how to think about their networks or interactions with other agents in the world, would be met with the response, well, it depends. This was frustrating to the modelers, but we could run through a string of different examples of ways of creating these agents that both defied standardization and seemed to defy association with different regions, demographics, land use types, etc. We could say things like, farmers are the people most aware of the conditions around them, and they are the ones who are adapting to those conditions in the best way they know how. There was an extension to this. Farmers are supportive of efforts to recognize the commons and adapt to efforts to build resilience. And then we could turn around and give them examples about farmers who only care about the commons as locally understood, within their small region, but are unwilling to take action based on a broader understanding of the commons. Similarly, and throughout all of this, we described how farmers almost always were resistant to constraints on their efforts to maximize profits. Sometimes they used narratives that denied climate change realities. It was a small group that did that. Sometimes they simply used neoliberal narratives about freedom of choice and rights within the current legal system. And sometimes they relied on fatalistic narratives that rejected the common presumption that farmers care about being stewards of the land for the next generation, and instead noting that they are not farming for the next generation, but only for themselves because they know there won't be another generation. We also threw in examples of farmers who are supportive of efforts to do watershed restoration, but then digging into the reason for this, some of them would only support them if it benefited them locally, while others were very explicit that regardless of whether it benefited them or not, they wanted to support these efforts. And the examples multiplied. So how does one reduce the complexity of these actors in a manner that doesn't ignore the fact that complexity is what makes the socio-ecological relationship in the Rio Grande such a profoundly problematic space? By the time we began to delve deeply into the needs of the modelers to construct agents for an agent-based model, I began to feel a little bit like I was falling down a rabbit hole, like I had fallen, like Alice, into Wonderland. And at times, I also felt like my assumptions about what made good science and good sense had been so challenged that I was in some sort of mirror world, a looking glass world, where up was down and black was white. And this prompted my talk today to think through some of the themes that we've been struggling through in our collaboration around 4 central questions. How much complexity do we need when constructing our agents in an agent-based model? When might it be important to capture additional complexity? What are the limits of complexity in agent-based modeling? And a 4th question that we found that we're constantly having to address with those outside of our collaboration. How can we resolve the contradiction between complexity and scaling? So at the beginning of the collaboration, we asked, how much complexity do we need when constructing our agents in an agent-based model? And what we realized almost immediately was that we simply could not answer that question in the abstract. Primarily, we realized this when we asked the next questions that would arise from this quantitative query. How can we tell when there is too little complexity, too much complexity, or just enough complexity? We did not have a metric for answering any of these questions, so we knew that it would be, from a scientific standpoint, problematic to try to set these parameters in advance. And indeed, at its heart, this increasingly became a discussion about which characteristics of an agent would matter and which did not. We asked, do we have a good scientific reason for choosing one characteristic over another? Obviously, theories about which drivers influence which aspects of a socio-ecological system can provide some initial guidance, but how would you ever know which characteristics matter in any given system without an inductive, grounded theory approach that collected and assessed those characteristics in situ? In fact, this led to a thought experiment. Asking about which characteristics to include in an agent, I posed the question, do you need to assign each agent with their characteristic eye color? This, of course, was met with bafflement and quickly dismissed. How could eye color have anything to do with constructing an agent to model this socio-ecological system? So I followed with another question. Do you need to assign each agent with their characteristic skin color? Suddenly, the question became more meaningful, though not necessarily more tractable. This discussion about characteristics led to another question. When might it be important to capture additional complexity? Here we found different ways of thinking about this. At its heart, there is a sense that this is part of the testing of the model. One builds the model, runs it to see how it will behave, and if it doesn't seem to produce expected outcomes, then it has failed to pass what I would term a sniff test. It just doesn't smell right. So it might be important to add complexity to the agents. On the other hand, knowing that we were dealing with a profoundly wicked set of environmental problems in the Rio Grande, the anthropologists insisted that we include complexity from the beginning, even if that meant that the model outcomes seemed off. In this case, the priority was that the characterization of the agents from the beginning passed a real-world sniff test, and that the model needed to be tweaked to find compromise. All of which led us to a broader discussion. What sets the limits of complexity in agent-based modeling? And here I saw a number of factors. There were the obvious limits regarding computing, processing all of the potential iterations of highly complex agents. But there were broader limits, like a lack of data. We quickly realized that the real issue here was not simply a lack of data, but a lack of what the modelers perceived as relevant data, those data they needed to make their model work. This also highlighted the fact that what could make sense to the anthropologists on our team as important complexity to include could actually threaten the elegance of the whole agent-based modeling effort. And always lurking in the background was the problem that the more complexity we added, the more our characterization of the Rio Grande would appear to be unique, and that this would lead to limitations of quote-unquote transferability. Which brings me to my final question. Can one resolve the contradiction between complexity and scaling? This is what I also term simply the problem with scaling. So we've run into this issue regularly. We're asked, well, that is an interesting understanding of the Rio Grande, but how do you scale those results? I, as an anthropologist, understand the importance of this question, but I'm not always convinced that the question reflects a full understanding of the implications of this question. The reason for this is that the issue of scaling will always require a reduction in agent complexity, as it seeks common denominators for agents across vast scales, regions, states, nations, continents, or the globe. While this suits the purpose of model building, this also relies on building agents who are most abstracted from reality. Indeed, I began to feel that the insistence on scalability dismisses the importance of human complexity a priori in agent-based modeling, and it ultimately constrains innovation and understanding. And here is where I most felt like I was like Alice through the looking glass, because I was confronted by a curious world that seems upside down to me. One where we value an accurately complex model less if it evades scalability, while we value a large-scale model more despite the fact that it does a worse job of capturing complexity. So we are still in the early days of working through how we're going to deal with bringing together the complexity that we, the anthropologists, collected in our work with the needs of the modelers in our collaboration. But working through these questions continues to be critical, because if we're not listening to each other, those who are collecting the data on human complexity and those who are constructing agent-based models, then we cannot answer these questions. Ultimately, we find ourselves asking a bigger question. What is the level of compromise that we each support scientifically in our efforts to model wicked socio-ecological problems? Thank you, and I hope you'll have the chance to go look at my collaborator, Jennifer Koch's session, actually introducing some of the elements of the model in session C7.
Thanks very much, Jack. That was terrific. Just checking the chat to see if there are any questions. People may still be typing them. So that was a really fascinating discussion of some of the sort of navigating between the rock and the hard place in dealing with complexity. So based on some of your experiences with the Rio Grande, what would you take from this to the next project?
What would I take in terms of the collaboration piece, or sorry, just to clarify the question, the collaboration piece, or what in particular?
I guess you've been grappling with these questions of complexity. Would you go into the next problem with a sort of refined perspective on that, and what would that be?
Well, I think, as always, what I learned from this project, and so I was already a colleague with Jennifer Cook, who's leading the modeling piece of this project. But what I think is critical is to kind of lay out the groundwork in advance. Again, there are, for lack of a better word, scientific expectations within at least some branches of anthropology about what you do collect regarding sort of the complexity of real world life for the people who were studying. And the idea that you would go in with sort of a very short checklist because it would meet the demands of somebody else from another discipline becomes a bit problematic. At the same time, it's absolutely critical to find that compromise. And so the thing that I think I learned most about this is I'm really looking forward to working with other modelers. And before I can do that, I have to have this conversation with them to make sure everybody is on the same page. So I don't know if that's the kind of meta comment that you're looking for, but that's kind of that's what I learned from this.
Have the conversations at the beginning.
Right, absolutely. Have the conversations at the beginning and make sure that they're not they're taken seriously. They actually do become the groundwork for or the foundation for the collaboration.
Now we've got three more questions here. John's got a question, and there's two more in chat. We might not have room for the three. So John, do you want to start?
Maybe mine's a quick question. So Jack, you have this complexity and it's different complexity at different scales. So the question I'm wondering is, can you kind of approach the problem at different scales? Maybe you can have like a more detailed model at the sort of detailed scale, and then a simpler model at, you know, a kind of a systems level scale, and then be, you know, integrating things at the system level, and then go back down to the detailed like process level, and sort of take into account this complexity in that way.
Yes, and that is really one of our big goals, is to do precisely that. One of the things, again, it was hard for me to give this as background in the broader talk, but this issue of fragmentation across the Rio Grande is such that you end up getting these different pockets that often are sort of split first and foremost by kind of where the water is. And then you'll have a large reservoir that essentially resets things. And then you have a whole new system afterward. And so one of the challenges that we've been having is, or one of the ways that we've been approaching this is precisely that, is essentially creating these smaller systems that link together ultimately. One of the challenges is that, you know, is finding the commonalities to be able to do that kind